I want to welcome everybody to our second session of data science and technology. One thing I'm going to do is I may just turn off the video. I usually like to have it on maybe at the beginning of the class or the end of class, but during class, most of your visual focus can be on the presentation material. So we'll save a little bandwidth here. Okay, so first things first, we have had some folks who have just recently joined the class. What I will do is when I send out my after session email, I will include a link to our first recording. So the good news is now when you go to the class Collaborate, you can now view all recordings, and you will see that our first class, there is now a recording there. So what I will do is, if this is your first time attending, you'll probably feel just maybe a little lost this first session, but not to worry. What you can do is after class, when you get that email, I will include a link that will go out to everybody who's registered for the class, all sections, and you'll be able to view the first recording, and that should then make you feel a lot more comfortable. So just wanted to point that out. Now, the second item I wanted to mention is in week one, already have had some students saying, but what about the first week's assignment? So that's where I wanted to pick up today to make sure that folks knew what to do about the assignment. Now, the assignment you can find, and here I'll just show you, let me go it this way. So when you go into the content section of the course, and as I say, we've got some common folders, the syllabus, the final report guidelines, which we will also talk more about today. And then this folder has all the free ebook references that students can use. And if folks have any other suggestions for really good free ebooks, let me know. Treat this sort of as our class library. So for week one, anytime you click the little down arrow, it kind of opens up that weekly module. And if there is an assignment that week, I will have it listed. The other place where you can always find assignments is if you go into your grade book, and you can kind of see what assignments are there. Okay. So, and all you need to do is, you can see it's visible to students. It says week one assignments. The due date is next week. Again, that is flexible. If it comes in a few days after, that is fine. The key thing that you want to avoid is waiting till the end of the semester and then having a whole bunch of things that you have to get caught up on. So let's go ahead and click on this assignment. Now, each week, the assignments will vary. One source of assignments is a website called cognitiveclass.ai. A little bit about this website. This website is sponsored by IBM. It was originally launched as Big Data University, and they then switched it to cognitiveclass.ai. Some of the tutorials will come from cognitiveclass.ai. Other weeks we may do different assignments. I used to do a lot more with cognitiveclass.ai, but as the years have progressed, decided maybe some more variety is would be useful to students. So let's take a look at cognitiveclass.ai. So this is what it looks like, and you can sign in. You can register for an account, but what's nice about signing in is that you can sign in with things like Facebook or Google. And you can even use your school's Google account. There we go. And now you're signed in. So this is kind of nice. You don't have to create a separate username or login. So so one thing about this course, and maybe one thing to check out is let's take a look at what's available. So what is this site? It is a bunch of tutorials, workshops, labs that have been put together on a host of topics related to big data, data science. It has expanded into artificial intelligence, and it has sort of expanded into a bunch of different areas. And in fact, they now have so many courses that they've started to organize them into learning paths. So when you go in and look at individual courses, they have a couple hundred courses now. And so that's, that's kind of like walking into a library. Oh my goodness, there are all these books. And so what they have started to do is they've started to kind of organize these courses into, you might think of as learning threads. So notice they have things like retrieval augmented generation. Using and what that is using large language models to help with data retrieval. They're experiencing now, they've got a learning path for generative AI and machine learning. They have now a set of courses for using PyTorch. They have, again, AI is the big thing now. They've just been adding a whole bunch of AI stuff, but they've got a learning path, natural language processing and sentiment analysis. They now have a learning path for machine learning for healthcare, image processing and generative models. Again, large language models, data science essentials, working with DevOps, enhancing applications with embeddable AI. That is something that we're going to see all over the place. Even in our bachelor's in web design and development, now when you design a web page, you may be wanting to incorporate a chatbot. And what do those chatbots use? A lot of them are, using, AI to help them with their functionality. So you may be using a chatbot, and this chatbot, that you're going to configure is going to have some AI capabilities. They've got unsupervised machine learning, computer vision, machine learning, applied data science with Python, big data storage and retrieval. Maybe you're interested in how do you administer a computer cluster. So they've got data science for business, deep learning, reactive architecture. Reactive architecture is an area that has basically says, how do you design your systems so they can handle change? That's really all reactive architecture is. It's not necessarily one particular technology, but it's a way of thinking about, I'm designing my application. I know that there's going to be changes. So think about, for example, your Amazon, you go on to Amazon to do shopping. If you're Amazon, you have this e-commerce business, you have this website, you want it up 24/7. You want it, but at the same time, you've got to roll out security patches, right? You may have updates to the operating systems. You may need to be able to respond to having to route traffic because you either need in order to maintain your service, maybe you need to bring more machines online, or maybe this is a slow time and you can save some money by taking some machines offline. So think of this like, a regular physical store. You go into Kroger's and they have, 10 lines for checking out. Do they always have 10 lines open? Well, no, if it's slow, they only have 3 lines open. But if it's a rush, maybe right before a snowstorm, they may even try to open up some additional lines to be able to handle the volume. So reactive architecture is really just a set of principles that says things like you should think about designing your system so that it can scale up, when it needs to take on extra work, and it can scale back when it's a slow time and we can save money. It's the idea that you want to build your application in a very modular fashion. So when you need to make an update, you're touching as little of the system as possible. So it's the idea that if I have to change this particular module, I don't have to take the whole system down to change that module. There's ways that I can make the update so that the rest of the system can function while I'm making those updates. It's about the idea of using things like messaging. And you might say, well, why would I want to use messaging? Well, it's kind of the idea, let's say you have an application and it's using an AI chatbot. And you decide, I don't really like that vendor. I would really like to change to a different AI chatbot offered by another vendor. Wouldn't it be nice if you could just, like a light bulb, just unscrew that particular chatbot and then just screw in the new one? And so that's sort of the system equivalent, that what we'd love to do is create our system so that it's easy for us to take a component out and put a component in. And as long as the different components are using the same messaging protocols, it means I can very seamlessly replace a module with a different module. And this is the trick, as long as they're using the same types of messaging, so that it's very easy for me to make that change. And as long as the protocols for talking with this new module are the same as the protocols for talking with the old module, very easy to mix and match. So reactive architecture is really, this is a set of courses that talk about really when you're designing and planning for systems. What are the, now if you will, the building principles that companies are using to ensure that they can keep their applications running 24/7 and that they can basically respond to change. So it's really architecting for change, and in such a way that your system never, let me put this way, never is a theoretical term, but it's the idea that you want to avoid downtime as much as possible, and you want to preserve the consistency of the user experience as much as possible. Okay. They've got packages in R, in case you're interested in R, of course, Python, running big data on an IBM platform. They also talk about some of the new development ideas. We talked about, there was DevOps, how can we be able to deploy new versions into production and have it very seamless. That's basically coordinating our development with putting new versions out into production. But other things, and again, this will often tie into reactive architecture, is using things like the notion of packaging up my software and the libraries that it needs into a container. so that when I deploy a container, my software and libraries can run. Very easy if you think about deployment, because I can just deploy out a container. But the other notion about containers, again, is we're trying to, again, goes back to all this change. We want to make sure that maybe changes in libraries or changes in operating systems, if we can kind of bundle things into these containers, it makes management easier, and it also, if you will, protects the system from going down because of a change somewhere else in the system. So I like to think of containers kind of like Ziploc containers. So think about your refrigerator and think about, those plastic containers, and you can put your food in and you can stack that food into your refrigerator. Well, it's the idea that containers work very much like that. So the food items that you're going to want to access on a frequent basis, you want to put that at the top of the pile, right? Because if you put that at the bottom of the pile, that means you have to go through all the Ziploc containers on top to get it. So the things, though, you want more frequently, you put at the top of the stack. But what's nice about those containers is if you want to, again, choose a different entree or choose a different dessert or choose a different side, you just reach in and you select a container. And what's going on with, other parts of those other containers is not going to impact. So this whole notion of being able to package our system as these, what we call microservices. So again, it kind of goes back to now, rather than trying to build one monolithic system where everything is tied together really closely, instead we want to think about our system as interchangeable parts that use messaging to talk to each other, and they're all using the same similar type of messaging protocols, and everything is bundled up in these interchangeable parts to make it very easy to update and make changes, and to make sure that a change in one container is not going to mess around with our other microservices that are stored in other containers. So it's a very interesting, again, it's part technology, but part of it is now the cloud services that support this deployment. You may have heard of Dockers or and Kubernetes, but it's also conceptual, meaning it's sort of a new way of thinking about how we design and deploy our systems. So, so again, they've got yes, they've got all of these. They've got Spark, Scala, and so forth. And what's nice is this is all free, and you are welcome. This is available to you. You can do this at, let me go this way, you can explore cognitiveclass.ai anytime you'd like. This may be something that you'd like to continue on in the summer. This site is up, hopefully, 24/7 year-round. So it's a very nice resource. And getting back, you might say, so what does this have to do with the first assignment? Well, for the first assignment, I wanted to get people thinking about their project. And that really raises the question, so what are the steps? What are the phases? What are the tasks that are part of doing a data science project? And so we'll talk about that, but there's a couple good courses. Let's take a look. There is some of the courses that I have picked out, and these are all with the theme. So what I've tried to do is if I have a topic that I'd like you to cover in cognitive class, To help make things easier, because there are hundreds of courses, I've tried to pick out those courses that are part of the theme. The other thing is a number of these classes tend to overlap. So what I've tried to do is give students a menu, because we've got all kinds of students. We've got PhD students, we've got master's students, we even have senior undergraduates who are going to be taking this course. We have students, coming from data science backgrounds. We have other students who are coming from education or business, or they're coming from engineering. So with all the different backgrounds, what I've tried to do is, whenever I can, give students a menu so you can take a look at the course to say, what looks most interesting to me? So, for example, for the Big Data 101, you can actually see an overview of the course. So Big Data 101 is a great introduction to, if you will, data science and looking at the steps in a big data science project. There's also one called Data Science 101, which is, again, kind of an overview, and you'll notice it'll talk a little bit about big data. This one, though, is a little bit more focused on data science in general, which could include both big data as well as not so big data. But it has some of the applications in data science, and it talks a little bit about, what a data scientist does. There's also data science methodology, and this one is just kind of understanding the steps in a data science project. But again, it will touch a little bit on, topics related to big data as well as to, what a data scientist does. And then the last one that students may find interesting is a little bit about what are the tools of data science. And again, it will cover, in covering the tools, it'll kind of give you an overview, a little touch of data science. So the thing for this assignment is you just need to select one of these tutorials. You're welcome to do more. If you're enjoying this and say, you know what, I have some extra time this week, this is really interesting, I would like to select some of the other tutorials, that is fine. For the purpose of what tutorial you want to focus on, keep in mind you just need to pick one from this list. Okay? I will also say they are constantly adding tutorials. Sometimes they're also taking tutorials away. So, and it's very fluid, meaning things could change like 2 minutes after I'm talking to you. If there's a tutorial that you spotted that looks really good and you think it fits within the theme of the week and it's not on this list, please let me know. They may have just added it. And if I look at it and say, yes, that's another great intro course, I'll go ahead and I'll add it to the list for everybody. I have also had the opposite happen, where people go to click on Big Data 101 this weekend, and all of a sudden it's not available. Sometimes that happens as well, because as I say, this is a vendor site and they are not working on the academic calendar. They're updating, changing, as they have people interested in working on those courses. Okay. So, how does this work? Well, let me just see. If I go to my learning, let's see. Let's see if it's smart enough. Let me just see. What do I have? Let me just see. 30. Let me just see. Let me just see if I have programs. Okay. Okay. So I've done some of these. Of course, some of these have uh, 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 disappeared. So, and we've got our learning paths. Okay. Okay. So as you can see, there is a My Learning tab where you can, take a look at you can put in a profile if you want. You can look at your account, and you can go to courses to see what you have signed up for. But let's just take one data science methodology. So all you have to do is once you've selected the course, you can go ahead and click on enroll, and you can start the course. And a lot of the courses, not all of them, but a lot of them have a final exam. And then the key thing is at the end of when you've completed the exam, and typically, just so you typically need like 70% or better on the course to be able to get your certificate. But the certificate will have your name on it, and it'll have the name of the course and the date, and you can download it as a PDF, and you can upload that to show, hey, I completed that tutorial. Sometimes sometimes cognitive class is kind of finicky, and sometimes, and I've had this happen, is that all of a sudden you've done the certificate, the class is complete, but for some reason they're doing an upgrade, and of course that's not good reactive architecture, because this shouldn't be happening if they're real good with their reactive architecture. But basically, a certificate is not forthcoming. Yes, you can put in a help ticket, but typically the other thing you can do is you can go out, and I think you can just print. Let me see, can I save it as a PDF? Yes, you can. They do have a tab where you can see your progress. And this is very nice, and it's nice to print out uh, um, the I was going to say, uh, it's it's nice to try to print out the whole thing. But what this allows you to do is this will show that you've completed the course. That's the other thing. So either the certificate or your progress. And ideally, it's kind of nice if you would also include, let's see. Yeah, I think that is fine. I was looking to see, when you do a printout, does it show your name? I was going to say, if you just wanted to edit the PDF to just stick your name in it, just to show, hey, I did do this. But as I say, these are, let me just wait, these types of tutorials are easy enough that I'm not going to, we'll kind of have pretty much folks on their honor system. So certificate is great, but if the certificate doesn't show up, just print out your course progress and just say on my honor, I did this. Okay. So let me just pause for a second, and let's see if anyone has any questions.
Yes, doctor, I have a question.
Sure.
Okay, so in a nutshell, you want us to select a course from the tutorials and then do the course and upload a certificate, or you want us to write a proposal on that topic and then upload it?
You don't have to write a proposal on that topic. You just complete a tutorial, and you can either submit the certificate or if you can't get a certificate, your progress report will actually tell me that you did 70% or better of the course.
Okay, so the certificate that we get, that will be like the assignment one, right?
That'll be the assignment one. And
Okay.
you have your choice. You can look at those different courses and pick the one that looks most interesting for your background.
Okay, thank you very much. That's my question.
Yep.
Can we select other courses?
Um, in terms of what will count for week one, it needs to be something from the list. But if you'd like to say, oh, but I'm thinking about doing a project in text mining, can I start looking at the text mining courses? Absolutely. So that is fine. But I will ask that students stay within, what's being, assigned that week for grading purposes. But for your own self-learning, you are welcome to explore whatever you'd like in cognitive class.
Okay, Doc, one more question. So,
Sure.
let's say I pick a course from cognitive AI. Can I also do another one from Big Data 101?
So let me put it this way. For week one, for grading purposes, you have to select something from this list.
Yeah, yeah, that's what I'm saying. If I select a course from cognitive class AI, and I'm done with that, can I go ahead and do one from Big Data 101 or Data Science 101?
You can do more than one, but you just need to submit one for grading purposes.
Okay.
So, if you end up doing several courses and you try to say, well, can I submit several certificates? Well, sure you can. I'm just taking the first one that I see. Yeah.
Okay. All right. Thank you.
And you'll notice I do put in like 2 attempts. The 2 attempts is just, sometimes silly stuff will happen. There'll be how it is, there'll be a glitch and your first submission didn't go through or went through with an empty file. And let's see, I think I've got, let me just see if somebody has already done one. Let me just, I don't know if Say is online, but let me just see, let's just see, let's see what Say, he went ahead and he's doing data science tools. And okay, so for Say, he's got his registration, which says that he's ready to begin the course, but the difficulty is he doesn't have either the progress report that says, oh, you're 100% complete and you've gotten 70%, or he doesn't have the certificate. But yeah, but this is very common. I mean, that's why we give folks a couple of attempts, because sometimes you're just practicing. You're just practicing to say, hey, let me see if I can get into cognitive class, and let me see if I can print out the page. This is one nice thing about Say is he did a screen print. And that did show, this is kind of nice, that showed his username up in the corner. So that's very nice. And that's the other thing. Could you do some screen prints just to capture, hey, look, here's my name, and here's, showing that I did the course, and it's showing that I completed and got a certificate. Yes, I'm okay with screen prints or PDFs. Yeah, that will work. So, but from my end, that's what I'm going to see. But this is why it's good. That's why you have a couple of attempts. Great. Other questions? always welcome to email. And there's particularly the first couple weeks, we like to answer a lot of questions because, hey, the first time you're doing things, they're kind of strange. Once you've had a chance to do it a few times, then it becomes like, oh yeah, I know exactly what I need to do.
Professor,
Yeah.
how many assignments will you provide?
Oh, yes. So typically, oh yeah, that's good. Let's take a look at the grade book and let's kind of see. So typically, we have weekly assignments. We usually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So we have basically we have a 14-week semester. And usually what I like to do is, here we go, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so we usually have 10 weekly assignments. And the reason why, the way I'm figuring it, is particularly when we get to April, at that point, I want students to have extra time to work on their projects. So that's why I don't have 14 weekly assignments for 14 weeks because, I have 10 weekally assignments, but the idea, and by the way, can you work ahead? Yes, you can. That's not a problem, particularly if it's a cognitive class type of assignment. Doesn't matter to me if you did a tutorial early. But the key thing is that project report and working on finishing up your data science project. You'll be putting more time on that later in the semester. So the last couple of weeks of the semester, you can really focus on your project report. But basically, it's 10 assignments and then the project report. And keep in mind, the project report, let me put it this way, the weekly assignments kind of assures that everybody who completes the weekly assignments will have at least a C in the class. And then in terms of the project report, typically if you have an A or a B on your data science project, that ensures you'll have an A overall in the course. And then if you're, having like if you have a low pass on your project, then you're assured of essentially a B in the course. And then if you didn't do a project at all, or it's really, thrown together really, really poorly, at least you'll get a C in the course. So, but that's usually how it works out. You do those weekly assignments and that gives you a foundation, but the key thing is going to be doing a good job on that project report, because one, that helps really determine whether you're going to get an A or a B or a C. But the other thing about the project is it's meant to give you something that you can show to an employer. So if you're looking for an internship or you're looking for employment, employers really want to see project work. They're less interested in grades now. They really want to see, show me a project. Show me what you were able to do. So what you want to do with your selection of a project is pick something where you can really showcase your ability to do data analytics, or maybe build something like an interactive visualization, like a dashboard, or that's kind of a hot thing right now, Tableau dashboards. I've had students who are interested in getting a job, and they saw that one of the requirements was to be able to work with Tableau. And so they picked a data science project where they could, not only demonstrate that they can analyze some data, but they wanted to show that they could build this nice Tableau community dashboard that would allow others to also explore and mine and work with the data. And what's nice about building with Tableau Community is that becomes a public dashboard. So it's something that you could put on your resume. So employers could actually go and see your dashboard and say, oh, that's kind of nice. So there's data science analysis, but there's also the ability to build these data science applications. So a dashboard, to my mind, is an example of a data science application. Other data science applications is maybe building a chatbot. That's an example. Yes. And so maybe you would like to, particularly if you're playing around, you're interested in text mining, you're interested in chatbots and AI. There are some, chatbot tools out there that you can start off at the free tier, and you can build a chatbot. And again, you can do a really nice report where you can describe, how you built the chatbot, how you got, what were the inputs that you needed in order to train the chatbot, how you tested it. And again, if this is something that you can kind of put out on GitHub or some other place that you can link to it from your resume, this is really helpful. So just keep in mind, employers today, they really could not care in some respects whether you got an A or a B or a C. What they really want to see is your work. And that's really is what's going to tell them, oh, well, that was a really cool chatbot. That was kind of clever. Or that was a really neat dashboard. Or they built a very interesting website to support some sort of aspect of exploring data or answering data. So that's another thing to think about. Or maybe you built something with Internet of Things. And that's one where, if you have a sensor and it's collecting data, you can have an IoT kit and you can have it deployed to a website, and the website can have a dashboard, analyzing or showcasing what information is coming from the sensors. So yeah, maybe you want to do an IoT project. Maybe there's something with large language models. So this is really important. If you think about as a graduate student, typically the rule of thumb for a graduate student is you spend roughly about 10 hours per week per course. And that's why 3 courses is considered just, really full time, because that's really, at least 30 hours. And again, if you're working on final projects and things like that, you may end up, some weeks may creep up, 12 hours or more. But you think, but I say for this class, think about 10 hours a week, and you can almost think of it in 4 parts, 2.5 hours a week on the class. So looking at the lectures, and then 2.5 hours doing the readings. And this is where some of the readings will be stuff that I put out, in the weekly materials, but you may be wanting to check out the ebooks. You may want to be doing extra reading or video watching on YouTube, or looking at blog sites, or you may want to be doing extra readings in cognitiveClass.ai. And then you then have the remaining time is working on the assignments. And this week, this is really easy. You should be able to do this assignment in about less than an hour. And but spend some time thinking about what you'd like to do for your data science project. And a good way to start is to think about what would I like to show a prospective employer. So kind of think about, what did I want to get out of my master's? What kind of job did I want? Do I have an idea of what kind of industry? So if you were thinking, I'd like to get into healthcare, Is there a data science project you can do related to healthcare? If you said, well, I'd like to do something that showcases my ability to do a dashboard. Okay, what might be an interesting dashboard project? If you wanted to showcase your Python skills, okay, can I do a Python notebook and I can really showcase my ability to use Python to analyze? Or did I want to show, am I looking for something in Internet of Things? Or is there something AI related? I wanted to get a job in AI. And so I do encourage you, think about, I was going to say, let's just see what's going on here. There's sites like dice.com. I'm just curious. I put in AI and yes. Yeah, you might just see, Capital One. Now, of course, you'd probably be not necessarily starting off as a senior. Oh, it's not found. Well, that's disappointing. What about this one? Skip down. Well, that is not working. Well, that's not. Let's see if this one's. Oh, hey, here we got success. Okay. Okay. Let me just make this a little bigger because you can hardly see it. Okay. Yeah. So one thing you may want to do this week, since we're not going to have too much in the homework, is do think career-wise. I always think it's how do you get the most out of your degree? Actually, you almost work backwards. Start off with your destination. This is where I want to be 5 years from now, and then work back to say, what do I want to get out of this course that will get me to my destination? So you may want to, oh, this is attractive. You see, check out that salary range. Ooh. Ooh. So what does this do? They build software which enable businesses to be more economically and environmentally sustainable by doing the supply chain. So of course the supply chain is how you get from your raw materials to your semi-produced materials to your finished materials to even to the point that after you're done using the materials, where do they go in terms of recycling, reuse, and stuff like this. So this is the frontier of logistics optimization, supply prediction, and demand prediction. And hey, even if you're new to supply chain, hey, there's plenty of YouTube videos and places where you can do supply chain 101. So what do they do? So what do they use? They use Go, TensorFlow, GRE/SQL, and various Google Cloud Platform tools. So this is important. You are not limited to saying, well, I'll do a project in Python. Maybe this is an opportunity for you to explore. Now, certainly TensorFlow would work well with Python. They work, but maybe you want to explore Go. I think that's Google, isn't it? Yeah. The Go programming language. There we go. Yeah, an open source programming language supported by Google. Yes. Yeah. So some of these tabs because they're driving me crazy. So yes, so you one of the things is, think about what you would like to do, what would you like to learn, what sort of skills would you like to develop, and that is part of. Let me put it this way. A number of these topics, by the way, like PyTorch and Keras, you can find tutorials in cognitiveclass.ai. So you can see what their responsibilities are. Okay, enhance, Okay, so you see what the response, and then here are the sort of the technologies that the background that they want people to do. And by the way, Cognitive Class does have a module on things like optimization and linear programming. So, one thing that you may want to look at is, if something like this appeals to you, of course, you can go, you can also check out the company, here we go. So these are the types of problems that they're working on. This is what they're the projects they're working on. Improving, driver utilization. Getting stuff from point A to point B as efficiently as possible with, trying to eliminate CO2 emissions. Moving freight with fewer trucks, eliminating expensive driver detention. So this is their business model. So you'll notice here, one of the things I want you to do this week is think about your career. Go to sites like LinkedIn or go to sites like Indeed.com or Dice. Dice.com kind of is a job search platform for technology. But you can go to Glassdoor, kind of think about, what do I want to do? Even if you're thinking I'm going to go on for my PhD, think about, but what kind of department would I want to be? Do I want to be working on government projects? Do I want to be working on academic grants? Do I want to be, working, in industry? What kind of project, what kind of solutions, what kind of challenges do I want to be working on? Think about that space. Think about companies that you might want to look at. Look at, sort of what kinds of problems do they want to address, and then think about getting a start thinking about thinking about what you'd like to do career-wise, and then start Googling ideas. So let's say supply chain data challenges. You can, let me just see if they have, what I'm looking for is, of course, one of the places you start off is just background reading. If I'm interested in supply chains, I'm going to start off just reading out, what's the supply chain? What are the challenges companies are facing with their supply chains? And then what I'm kind of looking for is and again, you can see what some of the challenges are. And then the next thing you want to see is, has anyone have Generally, what you're kind of looking for is once you started to get an idea, you want to start thinking about, yeah, where am I going to find some data for that idea? So, and sometimes you have to kind of search around. Okay. But generally, there is a data set available. I wonder if they have any, this is where you start searching. Once you start getting an idea, then you start to say who has logistic data sets. Let's see if that comes up. Okay. Once you start to get an idea, then the next thing that you want to do is start thinking, okay, I want to build something, but I'm going to need to have some data, or at least access to some data, so I can start building it. And this is where you start thinking about, okay, who has data? And what we're going to see is there's a lot of data out there. There are competitions and hackathons that have posted data sets. Kaggle is a source of data. But you'll be surprised if we go to sources like data.gov, we may find data sets that may be useful to us. There may be Northwestern University has put together everything from air traffic data. They have put together about 100 data sets that have stuff to do with transportation. So this is where you start researching. So let me just back out for just a second, just so we stay. Okay, so we're doing pretty well here. I want to make use of our last couple minutes here. Okay, so you'll notice here we talked about the assignment, and here are some of the readings that I'd like you to take a look at this week. And I'll put this into the email. But this was just updated last week. This is a neat little article from Ederica, which is a nice site. They have What is Data Science? A Beginner's Guide to Data Science. I'm going to let you, this is a nice overview read to kind of accompany, whatever tutorial that you're going to take on for this week's assignment. But this is what I want to focus on. Okay, let's just see if I can go right here. Okay. So typically in your data science project, the very first thing is discovery. And discovery is just coming up with a challenge or an idea for something you want to demonstrate your ability to analyze data, or you're trying to demonstrate your ability to create some sort of application like a chatbot or like a dashboard that would enable people to work with their data and to derive insights. So the discovery phase is thinking about what are you looking for in your data science projects? What sort of priorities? Certainly your budget can be zero. And here's what you want to think about is you may want to do just some background reading, meaning if you're interested in doing something with transportation because you'd like to work for a shipping or transportation company, you might just spend some time looking at job descriptions. You might spend time just reading about various companies, what they do. You might spend some time going YouTube, looking at, Transportation 101, just getting the background, the context, just so you can understand, the people, the technology, what it is you want to focus on. And again, what kinds of analysis that you want to do. Oh, and that's a good one. Let's talk about this for a second. Okay, so we mentioned that last period that there were sort of 4 types of things that your project might showcase. And by the way, you can do 1 of the 4 or 2 or 3 of the 4, but typically you might want to do something where you're showing your ability to do descriptive analytics. And this is, basically, exploring and, showing what is happening. Okay. And I should mention that if you are talking about, for example, understanding various measurements or counts, the types of things you may want to brush up on are things like making sure that you can explain things like showing, describing the center spread or a shape of your data. And that is something, we have a stats, 101 free PDF you can check out. You may check out visualization, everything from bar charts, pie charts, run charts, histograms, other types of charts. That might be very useful. You may also want to brush up on basic probability concepts. That is because when we make predictions or we're trying to understand our data, typically we know that there's always room for error. Usually we're not able to look at all the data. We look at a subset of the data. And there may be some discrepancies between our subset and the entire population. So typically, if you're testing a hypothesis, if you're testing a hypothesis about your data, our transportation times average around this amount or less. What's the probability that your hypothesis reached the wrong conclusion? So you may have remembered from statistics, you can be right, but you can also have a type 1 error or a type 2 error where, you went with the one conclusion when the other conclusion was right, or you went with the other conclusion when your null hypothesis was right. So that all comes down to probability. How confident can I be that I drew the right conclusions? And it all comes down, to thinking about the probabilities. Other things you may want to do in this area where you want to brush up on is, a lot of times you're looking for any correlations or associations. That might be an interesting pattern or trend that you want to explore. And there may be some basic data mining techniques. Are there any clusters? That might be very interesting to look at, or particularly when it comes to associations. Maybe you're looking to say there's an area called market basket analysis. First called that because it was first developed to say, what items tend to show up together in a shopping cart. But you can sort of ask that same question, what kinds of things tend to get grouped together? Now, again, these are the sort of the classic techniques that have been developed when you're doing measurements or counts. I should mention that there are, for other data, there are other specialty tools. And I'll give you an example. What if you have geodata? That means you might use, you want a GIS or, spatial analysis. Yeah. Yeah, particularly, for example, if you're tracking epidemics, what you want is a tool that will allow, like ArcGIS or Esri, that really allows you to look for patterns on a map. What if you're saying, wait, I'm not doing measurements and counts. I'm doing text. That's what I'm working with. I'm working with text. So you may be working with text mining or, text analytics. What about images? Maybe you say, no, wait a second. I want to do, I'm looking at a job where I need to work with images. I want to focus my project on image analytics. Well, then, what are the exploratory things you can do with, images? Or maybe you're working with sound or signals, and you say, okay, I got to research signal analytics. Or even things like, for example, if you're saying, no, I have a data set, and I'm looking at DNA, there are tools out there like DNA Subway, or Bioconductor, or that basically are libraries that allow you to do the types of analysis that a bioinformatician would do to try to understand what are the patterns, the sequences, what's the same or different from various strains of DNA. How can we differentiate, this virus from, it looks like this modified virus. So again, keep in mind when it comes to saying, I want to explore and show what is happening. Let me show what sort of patterns and trends and how I can describe this data. Keep in mind, if you're looking at measurements or counts, classical statistics looks great. But if you have other types of data that you may be working with, you may decide, I need to use other techniques. Okay. What about other questions that you may want to ask? All right. What if you want to say, oh, no, I'm doing diagnostic. That's what I want to do. Actually, you probably might do some exploratory, but you may be trying to you may want to try to do some diagnostics. So what are the techniques in this area? Well, some classical techniques is, if anyone's taken a course in statistical process control. So those are things like control charts, histograms, okay? That is very useful for trying to help us diagnose where we might have a problem or where there's a problem starting to occur. Also in this area, we mentioned correlation and association. Again, correlation, association is very useful. We might be using other techniques from root cause analysis. So even some brainstorming techniques like a fishbone diagram, or force field analysis. There are a bunch of techniques for trying to get to the root cause of a problem. We might be using techniques like you might need to design of experiments. This is big. A lot of times in manufacturing, they have to design some experiments to try to narrow down, what would best address this issue. And again, things like analysis of variance can be very useful. So if you're doing diagnostics, you'll notice that some of the techniques, you build upon, but some new techniques are introduced. What about if you're interested in making predictions? Okay. What are some of the things that you might want to be brushing up on? Well, again, depending on your data, and again, most of these techniques are very classic to things like measurements and counts. Certainly, if you're doing image analysis or sound analysis or DNA analysis, prediction might take a somewhat different form in terms of how do you do, prediction when it comes to like protein folding. But some of the techniques in this area are things like regression, and then we have many varieties in these areas. Of course, another way of doing prediction, if it's time-based, time series, is very useful in this area. Of course, we start getting into machine learning. We've got neural networks. You can even get into some deep learning, more complex neural networks. And then we can get into things like, decision trees. Other techniques that may help with a prediction is stuff like case-based reasoning. There's a whole bunch of specialty techniques. And then the last area that we may get into is if you're trying to do something that's more prescriptive. That is, we want to be able to recommend actions. Yeah, now we're getting into things like AI techniques, for trying to build maybe that's something you want to do. Maybe you're trying to build a recommendation engine for something. That could be a neat, if you're interested in kind of building something that's interactive. Yeah, there's a lot of data and training involved and testing. But what do you have? You get a lot into things like optimization methods like linear programming, genetic algorithms. Yeah, those can help, recommend what's the best configuration. Well, that means you want the optimal configuration. Simulation and analysis will fall into this area, doing some sort of simulation. Maybe decision tree scenarios, kind of like decision analysis. Yeah. All right. Oh, and we are just, we're giving one more minute. So basically, I think we're doing great here. So kind of the thing that I like you to go into this weekend with is, first of all, get your mindset together. What problem or challenge do you want to focus on? Yep, that's the first thing. Work on your mindset. But then, once your mind starts to get clear, think about, and this is what we'll talk about next week, is data set. Think about where you can get the data to help you. Yeah. So we need to talk about that next week. And then start thinking about skill set. What data science skills would help you to work with that data. And then the last thing you'll have to think about is the tool set. What type of data science tools would be useful? So, you start off with a problem and you decide, I want to be able to predict this. Then you have to think about, so what data would help me to do that prediction? And then you have to think about, for this prediction, I'd really like to try out some tools like decision trees, logistic regression, maybe a neural net. Well, now you have to educate yourself about those things. And then, of course, nobody is going to do those tools using pencil and paper. So that means, we got to find a package or a library that I can then tell it, hey, here's my logistic regression model, go calculate it for me. Or here's the decision tree, go calculate it for me. Or I want to try out this neural net configuration. Here's the configuration, go calculate it for me. So those 4 things, that's what we're going to be building on for next time. Reinforcing your mindset, thinking about then the data set, the skill set, and the tool set. And that's so folks get an early start in January, so you have lots and lots of time then to put into the project this semester. So with that, it's 2:58. I'm over time, so we will wrap up, but I will stick around in case anyone has any questions. So otherwise, feel free to get to your next class. Sure. Should be, I think, a neat semester. And I will put everything into an email overview that will go out after class. So don't worry, the readings and everything. I'll put those highlights into our weekly recap.